Hi everybody, today we're going to talk about solids. We spend a lot of time on gases and on liquids. We're going to spend just one day or even less on solids. Again, solids don't get a lot of respect in chemistry just because chemical reactions need collision of particles and it's very hard to collide solid particles. So we're going to start with the main difference between solids, liquids, and gases. If you have the same substance in all three phases, the main difference between them is the intermolecular forces. So we said, according to kinetic molecular theory, even though there are intermolecular forces, we assume that they are negligible in gases because the particles are so spread apart that attraction is negligible. In liquids and in solids, the particles are really attracted to one another because they are pretty close to each other. In solids, even more so than in liquids, because in most substances, the particles are slightly closer in a solid than they are in a liquid. The big exception to that is water, of course. And then also because of the crystal structure that the solids exist in. So here are some properties of solids that you all know about. It should just be review. So a solid retains its own shape. That's because the particles are stuck in their crystal structure. They're just vibrating in place, and so they cannot slide around each other to take the shape of the container. They have a definite shape. They also have a definite volume. That's because the particles are compacted together, and again stuck in that crystal structure, and so they cannot take up more or less volume. Solids are also not compressible. That's because they are very compact and condensed together, so there's not very much spaces between them, so you cannot compress them to take up less volume than they already do. Diffusion within solids occurs extremely slowly, that it's negligible. We would say that solids don't really diffuse. Liquids and gases do. Gases diffuse very fast, relatively. Liquids diffuse slowly. We'd say that solids don't really diffuse. And then solids also do not flow either. There are two types of solids. We have crystalline solids, and then we have amorphous solids. We're going to go more in depth with crystalline solids. Crystalline solids include three different subcategories: metallic crystalline, ionic crystalline, and molecular crystalline. So all three of those are crystalline. And then amorphous. Most solids are crystalline, so we're going to spend some more time on crystalline in a minute. But let's define amorphous real quick. So amorphous solids are solids that have random, non-repetitive arrangement of the molecules. So they do not have a nice crystal structure with repeating units. They're more random. So if you take a look at the way that the particles are organized here, there's not really a nice pattern that repeats. Very few solids are amorphous solids. Glass is considered amorphous, rubber, plastics, things that you think of as not necessarily holding their shape very well. So, like Play-Doh and rubber and plastics kind of can slightly take different shapes a little bit. Those are usually amorphous solids. So for amorphous solids, all you need to know